Here we'll go over how to plot the graph for an absolute value function by selecting random x values and finding the y values that go with it. This will be similar to plotting a linear function, except for an absolute function, we have a few more steps in our calculations, and we'll likely need more x values than what we used for our linear function. The reason for this is because an absolute value function has a v-shape, and we need to make sure we select enough x values in order to be able to find that v-shape. If we don't select enough x values, we could end up having a function that looks linear even though we know, based on this function, that it should not be linear because we have the absolute value bars. Let's begin by making our table for x and y, and we'll select more x values this time. We'll use -2, -1, 0, 1, and 2. Now let's find the y's that go with them. We'll begin by placing a -2 wherever we see the x in our absolute value function. We would have absolute value of 2 times -2 plus 2 minus 3. If we do the math, we'll have 2 times -2 will give us -4 plus 2 inside the bars, with a minus 3 outside the bars. -4 plus 2 will give us -2 inside of the bars. Then we subtract 3. But -2 inside the bars is really just +2, because when we take absolute value of a negative, it will change to positive. So we'll have +2 minus 3 will give us -1. So our first point is -2, -1. We'll write that underneath the graph, and we'll plot that once we do all of our calculations. Let's repeat this process for if x is -1 instead. I've made a new copy of our function. Now we'll take 2 times -1 will give us -2 plus 2 inside the bars minus 3 on the outside. But -2 plus 2 gives us 0, so we'll have 0 minus 3, which gives us -3. So our next point will be -1, -3. -1 from the x, -3 from the y. I'll make another copy, and we'll run the calculation again as 0. Now that I've made the new copy, we'll take 2 times 0, which will give us 0 plus 2 inside the bars, minus 3 out of the bars. 0 plus 2 will give us 2. This will stay positive because it's inside of the absolute value bars, and we'll have 2 minus 3 once again, which will give us -1, as we know. Therefore, our next point will be 0, -1. Now we'll plug in +1 in place of x. If we take 2 times 1 inside the bars, we will have 2 plus 2 in the bars and minus 3 outside of the bars. But 2 plus 2 is 4, minus 3 outside will give us +1. Therefore, our next point will be 1, 1. Now, one more time, we'll do the math for x equals 2. We will have 2 times 2 plus 2 inside the bars. The 2 times 2 will give us 4 plus 2 inside the bars, minus 3 outside. 4 plus 2 will give us 6, minus 3. This will give us +3. Our final point will be 2, +3. Now we'll place the points on the graph. Our first point is -2, -1. We'll locate where x is -2, and we'll go downward to where y equals -1. That will give us this point. Our next point is -1, -3. Let's mark down where -3 is, and we'll go left 1, down 3 to give us this point, which we'll label as -1, -3. Then we'll have 0, -1. That will be this position. Our next point will be 1, 1, so we'll go right by 1, up by 1, make another mark. And then 2, 3, so we will go right by 2, up by 3, place a point at that intersection, and we'll mark that as 2, 3. Once we've made our marks, we can use the dots to help us draw the V-shape. I'll draw that in orange here. You can see on the right side of the graph, we have 4 dots in a row in a diagonal line. It looks something like this. And then on the left, we have 1 dot, and that shows us that the other side of our V-shape should look something like this. We will draw left and right arrows to show that this absolute value graph goes on to infinity. And so this is how we plot an absolute value graph. You can see that this takes quite a bit of arithmetic, and so there are various shortcuts we can use to graph this a little bit faster. In order to graph an absolute function without plotting, we're going to have to start by finding the vertex. To begin finding the vertex, we're going to set the inside of the absolute value bars equal to 0. The reason we do this is because an absolute value can't be negative, so the lowest it can go is 0. We'll start by saying 2x plus 2 equals 0. Now we'll solve for x. Therefore, we'll subtract 2 from both sides. This will give us 2x is equal to negative 2. And then we'll divide both sides by 2, and this will give us x equals negative 1. Now, it turns out we don't have to calculate the y value at this vertex because it's already in the equation here at the end. The part outside of the bars is going to denote the y value at the vertex. Therefore, when x is equal to negative 1, y will equal negative 3. Therefore, our first point will be negative 1, negative 3. Let's place that on the graph now. From the origin, go left by 1, down by negative 3. Now, just like in a linear function, we will look for the rate of change. Just like before, that will be the number that is attached to x. In this absolute value function, our rate of change is inside of the bars next to x, and that's positive 2. Now that we know the rate of change, rather than going right by 1 and up by the rate, we will go both left and right by 1 and up by the rate. However, if there is a negative outside of the absolute value bars, we would go down instead. If there is a negative number to multiply by, it would be written where I'm circling in orange, in between the equal sign and the bars. If this number is positive, or if there's no number at all, we will go up, and then if it's negative, we would go down. Since we have no number written in that position, we will go up by the rate of change. So on our graph, let's go right by 1, which will place us on the axis, and then up by 2, and place a new dot here. Then we'll go left by 1, and still up by 2. Now we'll connect our dots. You can see we have the beginnings of a V shape here, so we will draw a straight line upward and diagonally to the right, and again on the left. If we like, we can calculate the position of these new dots we've drawn as well. To do that, we'll begin with our point negative 1, negative 3, which was our vertex. To find the point on the right, we will go up to right 1. If we have negative 1 and negative 3 and we go right by 1, negative 1 plus 1 will give us 0, and negative 3 for our y, and then going up by 2 will give us negative 1. Therefore, this point on the right we've drawn will be 0, -1. If instead we go left, we will be going left by 1 and up by 2. To find our new point, we'll have -1 from before, and then minus another 1 if we're going left. This will give us -2 for our new x. And then our y in the vertex was -3. If we go up by 2, we'll have -1. Therefore, this point on the left will be -2, -1. And so this is how we draw an absolute value graph without plotting a lot of points.